Hello everyone, my name is Carlos Olivas, and this is the video for the second project Logic Gates from the Electromechanical Systems class conducted by Alexander Gomez. And on this video, we will discuss on 4 different types of logic gates and how they work. First, as you can see, we have the buffer logic gate. How this logic gate works is that depending on the input we give our logic gate, then the output will remain the same. So for example, here we have the LED turned off. This is because our push button is not being pressed. However, if we manage to press our power button, then our LED will turn on. However, when we stop pushing it on, our LED turns off. This is because our input is now a 1 and then a 0. It's a 1 and a 0. So we manually need to give it an input for it to work. So that's how this logic gate works. Okay, so next we have the NOT logic gate, also known as the inverter. Since this logic gate inverts the input we give them, so for example, if this logic gate has an input of 0, then its output will be 1 and vice versa. Similarly to the last logic gate, this logic gate only has one input. Thus, it only has like 2 options to operate. And on this circuit, what we have here is that our light is connected to ground, so therefore our light will always remain turned on. However, whenever we push the power button, all the current goes to the transistor and then the LED turns off. So that's how this works. Next, we have the AND logic gate, and as you can see here, we now have 2 inputs. Therefore, we have 2 push buttons. And how this logic gate works is that it needs both of its inputs to be the same in order for it to work. So let's say now that we are not pushing any of the buttons, our LED is turned off. And if we were to push just one, then our LED will also not turn on. However, if we manage to push both buttons on, then our LED will turn on. And if we were to just leave one pushed, then our LED is off. So therefore, both of the inputs need to be the same for the output to be the same. Lastly, we have the OR logic gate. And contrary to the AND logic gate, this logic gate only needs one of the 2 inputs to be positive in order for the output to come in the same. So for example, for the last logic gate, we needed both inputs to be the same in order for the output to be the same. However, in this one, we just need to push one button for the LED to turn on. It doesn't matter which. And we also can push both of them and receive a positive output. So basically, you just need one positive input in order to get a positive output. And that would be all of the logic gates covered for this project.